Hi everyone, we couldn't meet for a long time, but inshallah we can make up this lost time. Let's start with our chapter Electromagnetic Waves. Students versus electromagnetic waves. This is round 2. As you remember, in round 1 we talked about some properties of electromagnetic waves and generation of it. Now we will start with transmission of electromagnetic waves. First, we must say, in order to transmit and receive electromagnetic wave, we need two basic devices. So let's say principles of electromagnetic waves. We need two basic devices. The first one is oscillated circuit. Also, it is called resonance circuit. Actually, it is mentioned in chapter 3, so we haven't talked about it yet, but let's explain it shortly. An oscillated circuit contains two devices, electrical devices. The first one is capacitor and the other is coil inductor. Here the capacitor is variable because we will change its capacitance to set frequency of electromagnetic wave. And the second thing is the necessary device is the second one is antenna. Antenna is a device which contains two separated wires like that. Also, it has different things. And here, as you remember, generation, charge moves up and down, the electromagnetic wave is produced. These two devices are necessary to transmit and receive electromagnetic wave. Now, in oscillated circuit, actually, I forgot, the frequency of the circuit is called, I said oscillated circuit is resonance circuit, so frequency will be resonance frequency. And frequency of the circuit can be calculated by 1 over 2 pi root of, remember, L is coefficient of self-induction of inductor, and the C is capacitance of capacitor. We can change capacitance of capacitor, so we can change the frequency, we can set the frequency. Now, antenna. In order to transmit electromagnetic wave, we will see in the book, half wave antenna is the use, and it is the best one. Half wave antenna. Why half wave antenna is the best one? What does mean half wave? That means length of the antenna equals half of the wavelength of the electromagnetic wave. Let's throw away. This is our wave, and let's assume this is voltage versus time graph. Here, the length of the wavelength of the electromagnetic wave is, or any wave, is distance between two crests or distance between two troughs. But when we talk about an antenna, let's draw it again. I'll use another pen. This is our antenna. At the end, voltage is maximum. At two ends, voltage is maximum. And at middle, the current is maximum. Here, we will compare a wave antenna, half wave antenna, and quarter wave antenna. What will happen? Here, if the voltage is maximum, that means here we will use A and B points, two crests. Now let's start with antenna, which its length equals wavelength of the wave. Here, I'll draw our antenna. This is our antenna. What we said, A and B, two crests, two maximum points. Let's draw the graph. Here is point A and here is point B, like that. Now, here is point A, here is point B. At the ends, as you see, voltages are maximum. Now, if the length of the antenna, as you see, equals wavelength of the wave, here positive, negative, negative, positive. What will happen there? Here, unfortunately, positive will cancel negative, will cancel negative, will cancel positive. So there will be, unfortunately, we are so unhappy. There will be no transmission. So what will happen? We will use an antenna which length equals half of the wavelength of the wave. Yani L equals lambda over 2. Now what will happen? let's draw our wave again. This is our wave. Now, here two crests, this is one wavelength, right? Up here is A, now here is B. This is half wavelength. Let's draw our wave. Oh, here is A and here is B. As you see, this length is half of the wavelength. So here is A, here is B. Here is positive, here is negative. Remember generation. Positive moves up, negative move down. And so we are so happy because there is transmission of electromagnetic wave. And that is another method which is called quarter wave antenna. Quarter wave antenna. What is that? Here we have an antenna, but one side is grounded. So we can consider there is only one side, the upper side. If we draw wave like that, here only we have positive, whereas the other imaginary takes place under the ground. So in the quarter wave antenna, there is transmission, but we are not so happy because the best one is quarter wave antenna. I'm sorry, half wave antenna. And this is wave antenna. We are so unhappy because there is no transmission. Two examples on page 148 and 149. Please connect me if you can understand, if you cannot solve. If you can solve it, there is no problem. Now we will explain transmission and reception circuits. First, let's start with transmission circuit. Previously, we said in order to transmit or receive electromagnetic wave, we need two basic devices. The first one is oscillator circuit, I will write shortly, and the second one is antenna. I want to explain transmission circuit by picture. Oscillator circuit, as you remember, has a variable capacitor and it has coil. And antenna, we can draw it like that. Now, when oscillator circuit is connected to AC source, supplied by AC source, the electric waves are produced. And when these electric waves are linked in the antenna, the induced current and then electromagnetic waves are produced. And the frequency of the electromagnetic waves can be set by changing capacitance of capacitor. So it is variable capacitor. For example, if you want to send a 50 Hz frequency electromagnetic waves, change capacitance of the capacitor, then you can set the frequency of the electromagnetic wave. This is transmission circuit. AC source is connected, so electric waves are produced and they are linked in the antenna. Because of producing induced current in the antenna, electromagnetic waves are produced. The reception circuit is opposite of that. Reception circuit. I write shortly. Reception circuit. What's the reception circuit? We have an antenna, there is coil, and we have oscillator circuit, variable capacitor. Here we have coil. When electromagnetic waves reach our antenna, the induced current are produced and electric signals are linked in the oscillator circuit. So what will happen? For example, if we want to listen radio Sabah, we will change capacitance of capacitor, so we will set frequency to 95.1, I can't remember, 95, 98, like that. So you can listen radio Sabah, you can listen all the last music, and you can listen all last themes. Or if you want to listen to FM, you will set 90.1, and you by changing capacitance, and you can listen to your radio. Now, detecting electromagnetic waves. As you remember, electromagnetic wave and electromagnetic wave contains both electric field and magnetic field. And energy of electromagnetic wave is equally distributed between electric field and magnetic field. So if we want to detect electromagnetic wave, we can use its electric field and also we can use its magnetic field. The first method is uses its electric field, detecting electromagnetic wave by its electric field. What will happen? Let's assume this direction is y direction, positive y direction. And electric field of electromagnetic wave oscillates between positive y and negative y like that. If electric field is directed to up and down, that means the charge will be directed to up and down. And when electromagnetic wave reach antenna, the positive charge move up and down like that. So varying electric field on the antenna produces induced current. Remember, reception. Induced current produces electric signals. Then you can set the required frequency and you can reach your goal. The second method is using magnetic field of electromagnetic wave by its magnetic field. We can draw the magnetic field of electromagnetic wave like that. This is B and B. You can consider plus set or minus set or another method, out of the page into page, out of the page into page like that. We cannot use same method. We must use another antenna to use magnetic field of electromagnetic wave. We will use ring. Remember, if there is closed loop in the magnetic field, if loop moves, or on the other hand, if magnetic field changes on the loop, the induced current is produced. If this antenna is connected to oscillator circuit, you can set your one frequency. What will happen if the magnetic field changes on the loop? We can consider magnetic flux change, that is change in flux. If the magnetic flux changes on the loop, the current is produced, and also you can detect your electromagnetic wave, its frequency. Now we will explain modulation. I will explain that. What is modulation? Consider the rider has low speed and the horse has high speed. So rider is, this is our horse, speed horse, like that, and this is our rider. The low speed rider is carried by high speed horse. Why? Because rider cannot travel over long distances like that. So he uses high speed horse. The modulation, same thing. In modulation, for example, when you speak to microphone, the audio waves are produced, and these audio waves have low frequency and they cannot travel over long distances. So they need a vehicle. What will happen? In modulation, low frequency audio waves are carried by high frequency radio waves. This is called modulation. Low frequency audio waves, this is our audio wave, this is rider, are carried by high frequency radio wave. This is called modulation. There are three methods for modulation. As you know, the wave has amplitude. This is our wave. This is amplitude of the wave. And the frequency of the wave, it has frequency, and also it has phase. When one of these quantities is changed, that means the these three methods are, the first one is AM, means amplitude modulation. Amplitude modulation. In amplitude modulation, the amplitude of the wave is changed by changing amplitude of the audio wave. Shortly, we can say if the amplitude changed, the modulation is called amplitude modulation. If the frequency is changed, the modulation is called frequency modulation. And if the phase is changed, the modulation is called phase modulation. In amplitude modulation, this is our, for example, carried wave. This is our audio wave, low frequency audio wave. And here we have high frequency radio wave. This audio wave, low frequency audio wave, is carried by high frequency radio wave. So it is called carried wave, and this is called carrier wave. At the end, we have a wave up like that. Here the frequency is same frequency, same frequency, same frequency, same. But as you see, the amplitudes are different. So this method, this modulation, is called amplitude modulation. In frequency modulation, it is called FM. This is frequency modulation. Also, we have audio wave, carried wave, plus we have radio wave, it is carrier wave. At the end, we have a wave with same amplitude, approximately the same amplitude. The amplitude is constant, but as you see, the frequencies are different. So that means the frequency of the wave is modulated. This wave is, this modulation is called frequency modulation. And the last method is PM. It is phase modulation. This is our sweet carrier wave plus our analog radio wave, like that. At the end, we have a wave like that with different frequency and amplitude. The change in amplitude of radio wave change the frequency of the resultant wave, and this is called phase modulation. Now, range of radio waves. There are four basic ranges for radio waves, the four defined ranges. I'm sorry. The first one is very low frequency range. This range is between 3 kilohertz and 300 kilohertz. What is it? Very low frequency zone. And what is range? 3 kilohertz and 300 kilohertz. And where are they used? They are used in sea navigation. The second one is medium frequency zone. In medium frequency zone, the range is, first, what is its name, what is its range, and where are they used? What is its name? Medium frequency. And what is its range? 300 kilohertz and 3 megahertz. And where are they used? They are used in regular radio broadcasting, very low frequency, medium frequency. And there are two zones more. What are they? The third one is high frequency zone. The name. And what is its range? It's between 3 megahertz, 30 megahertz, and 30 megahertz. And where are they used? They are used in communication between airplanes and ships. And the last one is the fourth one, very high frequency zone. What is its range? It is, what is the last one? 30 megahertz and between 300 megahertz. Where are they used? They are used in TV broadcasting. They are used in air navigation control systems, and they are used also police navigation control systems. They are range of radio. Now, propagation of electromagnetic waves. The speed of an electromagnetic wave depends on two things. The first one is electric permittivity, and the second one is magnetic permeability. So we can formalize this relation. V equals 1 over root of electric permittivity and magnetic permeability. We know that electromagnetic waves travel in vacuum at speed of light. Let's prove that. The electric permittivity of vacuum is 8.854 times 10 to the minus 12. And magnetic permeability of vacuum is 4 pi times 10 to the minus 7. Let's use our formula. V equals 1 over root of epsilon times mu. Let's place numbers. 1 over root of 8.854 times 4 pi times 10 to the minus 12 times 10 to the minus 7. At the end, the speed will be 2.99 times 10 to the 8 meter per second, and it is approximately equal speed of. Electromagnetic waves, on the other hand, radio waves, are propagated in many ways. There are three basic types. The first one is ground waves. This is ground. If there are two transmission devices, antennas like that, and this is another antenna, the wave is sent from first one and reaches second one. These waves are called ground waves, and they cannot travel very long distances. They are limited, and they range between 2 megahertz and approximately 500 kilohertz. This is the first one. The second one is sky waves. In sky waves, this is ground. This is our antenna transmission devices. In sky waves, the ionosphere is used. The wave is sent to ionosphere like that, and it is reflected by ionosphere and reaches to point. But here there is an interesting thing. The ionosphere has two layers. The first layer is D layer, and the second layer is F layer. During daylight, there is D layer, but at night, D layer disappears. So at night, the wave will not strike to D layer, it will strike to F layer and is reflected by F layer of ionosphere, and it can travel more distances. This is a good question. What will happen at night, or which distance is longer than the other during daylight or at night? During daylight, ionosphere contains D layer and the electromagnetic waves or radio waves are reflected by D layer. But at night, D layer disappears and radio waves are reflected by F layer. So at night, radio waves, sky waves can travel more distance than daylights. And the last one is space waves. The third one, space waves. This is ground, and here we have transmission devices. Space waves means that here we have satellite. The wave will send to satellite, and satellite resend this wave to the required position. And the range of it is about 30 megahertz. This is called space waves. Let's remember again, ground waves, this is the limited waves. They are sent from one antenna to another one. Sky waves, the ionosphere is used. They are affected by ionosphere, but there are two layers during daylight. D layer exists, but at night D layer disappears, and radio waves are affected by F layer. And the last one, space waves. The radio waves are sent to satellite, and satellite will send radio wave to the required position. Now we are starting last part of Electromagnetic Waves Chapter 4, applications of electromagnetic waves. There are two important applications, radar and remote sensing. Let's start with radar. Radar is a device that detects position of the target. For example, it sends a wave to the target, and when the wave is reflected by target and reaches radar, and radar can detect its position, what is its range. So we will talk about parts of radar. This is radar. It detects the position and range of the target. Firstly, we need an aerial, because it will transmit and receive the waves. And what we said, radar transmits wave and receives the reflected wave. That means it contains transmitter and receiver. It will transmit or receive. That means we need switch. Here we have switch. Then, how can we transmit electromagnetic wave? We need oscillator. And who will modulate, or who will set the frequency of the wave? We need modulator also. And then receiver receives signals, and who will detect these signals? We need signal processor. And how can we see the position of the target? We need screen or monitor. This is an electric device, and we need a main control system. It is called mother clock. Okay, and these are the parts of radar. What is radar? it detects position and range of the targets, and that means it will transmit and receive the reflected wave. The parts, in order to transmit and receive, we need an aerial. In order to transmit, we need transmitter. In order to receive, we need receiver. We will transmit or receive, we need switch. And then the transmitter, in order to transmit electromagnetic wave, we need oscillator. And in order to modulate the oscillated wave, we need modulator. And then we will receive signals, we need signal processor. And in order to the position, we need monitor. And in order to control this electric system, we need a mother clock. This is radar and its parts. The second application is remote sensing. Its method very closer to radar. It is used in civil engineering, meteorology, agriculture, and military applications. In remote sensing method, we have a satellite like that. This satellite takes photo of the targets on the ground. Here we have buildings like that. Here we have trees, and let's assume here we have like. What will happen? Shortly, the satellite will send wave to the target, and the wave is reflected by target, and it takes picture of the photo of the targets. This is remote sensing. There are two different methods which are used in remote sensing. The source can change, and this is the first method, or the wavelength of the wave can change, and this is the second method. Let's explain that. The first method is remote sensing by power source. In this method also there are two important points. The first one is active image, and the second one is passive image. In active image, satellite send waves to target. So target reflects these waves to satellite and can take the photo of the ground. In passive image, target reflects the waves of natural source. For example, target resends the waves which are sent by sun to the satellite. From sun to the target, and target to the satellite. This method is called passive image. And the second main part of the remote sensing is remote sensing by wavelength. There are three things. What are they? The first one is visible range, the second one is infrared, and the third one is microwave. Image of the target picked up by wavelength, and there are three types: visible image, infrared image, and microwave image. And uses of remote sensing, where it is used. Firstly, in order to discover mineral ores, the first one, let's say uses of remote sensing. The first one is to discover mineral ores. The second one is monitoring natural movements, for example, river movements. Monitoring river movements. I read shortly, it is written in our book. The third one is studying construction projects. Studying construction projects. The fourth one is studying natural plants or soil quality distributions, and studying natural plants. My writing is very bad, I'm sorry. Then the fifth one is they are used in military applications, very dangerous. They are used in military. And the sixth one is they are used in imaging of stars, imaging stars or planets, let's say. Imaging planets. In last part, we will talk about mobile technology, the new method and the old method. I want to compare them to explain that. The old method and the new method. In old method system, the limited users can use the system. Let's say limited users, old one and new one. And this is mobile. Wow. And there are many users. In the old system, in this communication system, there is only 25 communication channel. But in this new system, in mobile system, there are 1,666 channels. In old method, there is only one area, region like that. But in new mobile system, the city or country or the world is divided into groups like that, and you can pass over each group and you can speak with your, let's say, darling, with your mommy or daddy without interrupting or without cutting anything. On all systems, there are limited users. In this mobile, there are many billions of users. There are 25 channels, there are 2N, and there are 1,666 channels. In old system, there is only one region, but in this new system, there are cells, and you can pass over the cells. See you, everybody. Inshallah, I will explain chapter 7 in the next